Hydrochloric acid is HCl, in case you didn't know. All right, start another video.
Oh, it's already started.
Okay. All right. Hopefully you guys got this for your work. Okay. Something I want to talk about first before we move on from this problem. So the answer, ask how much hydrochloric acid you're going to make. 1.67. So this is why this is a poisonous gas to us, because when we breathe it in, it reacts with water in our lungs, starts making an acid. What does acid do to our skin tissue? Starts eating it away. So that's why it becomes poisonous and basically you drown in yourself. But what I want you guys to pay attention is that, is the number of moles here in the after equal to the moles that we start with? It is not the same, right? Okay. Why is it not the same, or why does it matter? It's fine that it's not. It's because we already balanced the equation. Because you balance this equation, this doesn't matter anymore. This is already taken into consideration the law of conservation of mass. Okay? Masses can be different by number of moles present. Okay? So the balanced equation already took care of our law of conservation of mass. That's why the moles can be different on both sides. Okay. I'll let you guys on your own do number 5. I want to move down to number 6. So number 6, when you look at it, it says plus other, it's how much Coke is actually made. And the process and the secret ingredients and all that stuff. Like Coke one time tried to change their formula when I was a kid. People went up in arms, almost rated. That's why they eventually came with Coca-Cola Classic, which was the old flavoring, and they eventually just went back to it. But when you look at this problem, I know I changed it for you. I started with 40 grams. If you look at the problem, it says 40 grams, right? Now, the question is, or 40 grams of caffeine. You would have to change that 40 grams into moles before we go into the BCA chart. It's kind of what I want you to see, that you do that. Okay? So when you're looking at that problem, that's what it's asking for you to do. Okay? So that's all. Those are all about doing those type of problems. Okay. If you would grab out more stoichiometry practice. Grab out that worksheet, please. And we're going to do the first one dealing with mass issues. So if you don't know what it looks like, for you, for the regulars. Oh shoot, I did not share that with everyone. Dang it. For regulars, you'll see this later. You can just kind of copy it down. What we do with this one. Well, let me share my screen so we can all talk about this at the same time. Share screen. Or stoichiometry problems. All right, so when you look at this problem here, get this out of my way. Thank you. All right, it says 9 grams of aluminum reacts with an excess of phosphoric acid, producing hydrogen and aluminum phosphate. What is the theoretical yield and percent yield if only 3 grams of aluminum phosphate is produced? Ooh. So this has a little bit new things to it. And the only thing I want to do right now, we'll get back to about percent yield later. And with how we calculate that. But I want to just do the calculations of showing how to go into the chart first. Okay? Percent yield, we'll talk about more. Actually, I'll show it today. That way you have it, but we'll go from there. Okay? So, for the simplicity of time, I'll just tell you what the equation at the top is. Aluminum reacting with phosphoric acid, which I give you the formula of H3PO4. Oops. Produces aluminum phosphate plus.
Do we have this sheet?
You don't have that? I thought I gave that to you.
Find it.
Yeah, we didn't get that.
No?
We don't have that.
There, but not the back.
Let me see.
Yeah.
Yeah, it says more stoichiometry practice. It's an assignment.
But the actual attachment isn't there for us.
It isn't?
No.
Oh, that's not good. Let me go back. So how does I had somebody actually turn it in. I'm like, how did you turn it in if the assignment's not even there? Okay, second hour, I just loaded it up for you. I apologize. And sixth hour, you're all set now. But you guys can write the notes down as we go on, but you'll see how this prep is. Okay, let's kind of go through this. So when you read the problem, it says 9 grams of aluminum reacts with excess stuff, okay? So that's what you're looking at, aluminum, 9 grams. Can you put that directly into the BCA chart? Hopefully you're saying no, because for you to be in a BCA chart, what unit must you be in? Moles. So what I do, and it's okay if you do this, you can take 9.00 and divide it, because we're going from moles into moles. We divide by the molar mass. Divide by the molar mass of aluminum. I'm pulling up a periodic table because I forgot to pull up one, which is 26.98. So when you put that in your calculator, you get 0.333, right? Yeah, 0.334 technically. So it says excess phosphoric acid. So hey, look, extra stuff. That's what excess means. It means I have a lot of it extra that I don't need to worry about. It's going to react no matter what. 0, 0. Now again, see, that's how I got into the BCA chart. So I'm saying I'm using all this. How many moles of phosphoric acid am I going to use? Should be an easy number for anybody. By silence, I think you're confused on what it is. Ratio is 2 to 2, which means 1 to 1. Using that much. I don't have to do any more math for aluminum phosphate. Because it's 1 to 1, it is, I'm making 0.334. And this here is the only one I would have to do any kind of math for it. So you take 0.334 times 3 divided by 2. Actually, I should do the same number. .501. So we get 0 extra stuff, 0.334, 0.501. So right now what you have here, this is called, or these answers, both of these are technically, is theoretical. Basically, anything that you have, that you do mathematics for in a stoichiometry problem are considered theoretical. Means theoretically, this is how much I should produce. Does it happen all the time? No. You might produce too much or you might not produce enough, depending on environment and everything like that. So this is technically your theoretical yield. Okay, so that's your first part of that question. Now the next part of the question says percent yield. What is the percent yield? So ideally I should have made this. I said I made 30 grams of it. I need to see how much did I actually produce. So percent yield equals actual divided by theoretical times 100. So you need your actual and your theoretical. Both need to be same unit. Basically, either you can do moles divided by mole or gram divided by gram. So either answer is acceptable. If you wanted to use this 0.334, you can use that. That means you have to take the 30 grams that I gave you, because in the problem of 30 grams, that is your actual. In a percent yield problem, I'm always going to give you the actual. You will need to find the theoretical. Okay? So either way, you have to decide what you want to do. I'm going to change this into grams. So that would take me out of the BCA chart. So I take 0.334, times it by the molar mass of aluminum phosphate, which is 26.98 plus 30.94 plus times 16. So theoretically, we should have made this many grams of aluminum phosphate. Did we do that? Even my son who was watching, he goes, no, we didn't. Because the answer was, the problem said we had 30. So to find my percent yield, I'm gonna erase this part of the screen so it's easier for everyone to see. You'll take, so percent yield is actual divided by theoretical times 100. So our actual was 30.0 divided by 40. What did I say? 7. Put that in your calculator, see what you get. All right. So that's kind of how you do the percent yield part. You could have done the moles. You could have done 0.334 divided by whatever this in moles. So I took 30.0 divided by, was it 121 point, huh? Was it 121 point something? I forgot.
121.92.
Thank you. So 30 divided by 121.92. We got 0.246. That's your actual, divided by 0.334. And you should get around the same answer. Times 100. And I got 73.7%. Same answer both ways. Either way you want to do it, I don't care. You should get, see I did it here is doing the grams. Let me put units for you. Thank you for yawning really loud, Alexa. Mole, mole. Same units, okay? Have to be the same units when you do it. That is all the new stuff I'm going to give you right now. Is there any questions?